ఆల్టర్నేటింగ్ కరెంట్లో ఇంపార్టెంట్ ఫార్ములే AC. The current which is always in one direction is called DC direct current. Current which reverses its direction in equal intervals of time is called alternating current. Instantaneous current I equal to I naught sin omega t. Instantaneous EMF E equal to E naught sin omega t, or I equal to I naught cos omega t, E equal to E naught cos omega t. కాబట్టి current which is always in one direction is called DC. The current which reverses its direction periodically and represented by sine or cosine functions is called AC. I instantaneous equal to I naught sin omega t or I naught cos omega t. E equal to E naught sin omega t or E naught cos omega t. Peak value, here I naught be the peak value. I mean AC may be expressed in terms of peak value, mean value and RMS. I naught be the peak value of current. I mean equal to 2 I naught by pi, or E mean equal to 2 E naught by pi. RMS equal to I naught by root 2. RMS equal to E naught by root 2. Power average power equal to, in general, PDC equal to voltage into current, but in AC power equal to EMF into current into cos phi, where cos phi is the power factor, or P average equal to ERMS IRMS into cos phi. If cos phi equal to 1 in virtual or apparent power, therefore P apparent equal to VRMS into IRMS, or this equal to E naught I naught by 2 cos phi. ERMS అంటే సోర్స్ వోల్టేజ్ కానీ వోల్ట్ మీటర్ రీడింగ్స్ ERMS వాల్యూస్ అవుతాయి. DC కరెంట్ త్రూ ద సర్క్యూట్లో ఇవి అమ్మీటర్ రీడింగు, ఇవి RMS కరెంట్స్ అన్నమాట. ACR సర్క్యూట్, ఇన్ ACR సర్క్యూట్ E equal to E naught sin omega t and I equal to I naught sin omega t. Phi equal to phase difference, phase angle equal to 0, and P average equal to ERMS IRMS into cos 0 1 అవుతుంది. Power loss is maximum in ACR circuit. In ACL circuit, E equal to E naught sin omega t plus pi by 2 and I equal to I naught sin omega t. voltage leads current by 90 degrees. Here power loss equal to 0. Phi equal to 90 degrees and cos phi equal to 0 and power loss equal to power factor equal to 0. Inductive reactance XL equal to 2 pi FL equal to omega L, where F frequency. The AC L circuit. In AC, C circuit, current I equal to I naught sin omega t plus pi by 2, EMF E equal to E naught sin omega t. In this, voltage lags, current I leads E by 90 degrees. Capacitive reactance XC equal to 1 by omega C equal to 1 by 2 pi FC. For DC, XC equal to infinity means capacitor blocks direct current. In AC LR circuit, voltage EZ equal to root of EL square plus ER square. My current is always along x-axis. This is EL and this is ER. Resultant lies along this direction. This is phi. And impedance Z equal to omega L whole square plus R square, and tan phi equal to EL by ER or omega L by R. Here voltage leads current by pi radians. In AC CR circuit, EZ equal to EC whole square plus ER square under root, and impedance Z equal to XC whole square plus R square, and tan phi equal to XC by R equal to 1 by omega CR. Here voltage tan phi equal to, ante V voltage lags current by phi radians. In AC LC circuit, EZ equal to EL difference EC and impedance Z equal to XL difference XC. At resonance, XL equal to XC, EL equal to EC. XL equal to XC, and angular frequency omega equal to 1 by root LC, resonant frequency F equal to 1 by 2 pi under root LC. In AC LCR circuit, EZ equal to EL difference EC whole square plus ER square and Z equal to XL difference XC whole square plus R square and phi equal to tan phi equal to XL difference XC by R. Depending on XL is greater than XC, it acts as XL greater than XC acts as LR circuit. XL less than XC acts as CR circuit. If XL equal to XC, XL equal to XC, circuit is in electrical resonance. Resonant frequency F equal to 1 by 2 pi under root 1 by LC. This is frequency of LCR circuit at resonance. At low frequencies, LCR circuit acts as a capacitive circuit. At low frequencies, capacitive dominating. Alage at high frequencies, inductive dominating circuit. Inductive dominating. At certain frequency resonance omega L equal to 1 by omega C avutundi. At resonance XL equal to XC and VL EL equal to EC avutundi. Ivi LCR circuit, R circuit, L circuit, C circuit, LR circuit, CR circuit, LC circuit and LCR circuit at resonance. LCR, this is R, ER, EL, EC. This is LR circuit and this is CR circuit. Equal అయినప్పుడు circuit resonance లో ఉంటుంది. Transformer. Transformer is a device used to transform electric power in one circuit to other at same frequency. It is applicable only for AC but not for DC. It consists of two coils. One is primary coil which is connected to AC mains and other one is secondary coil which is connected to electrical appliance. ES by EP equal to minus NS into DI by DT by NS into d5 by dt by minus NP into d5 by dt. Flux same, rate of change of flux is same in both the cases. This equal to N secondary by N primary. According to Ohm's law, V equal to power P equal to voltage into current equal to ES IS equal to EP IP. EP IP. Therefore ES by EP equal to IP by IS. Transformer ratio R equal to N secondary by N primary equal to E secondary by E primary equal to V secondary by V primary equal to I primary by I secondary equal to Z secondary by Z primary. This is called transformer ratio. R is greater than 1 for step-up transformer and less than 1 for step-down transformer. In step-up చిన్న టేబుల్ step up, step down, property, EMF. మరి ఈ స్టెప్ అప్ ట్రాన్స్ఫార్మర్లో ES గ్రేటర్ దెన్ EP, స్టెప్ డౌన్ దీనికి రివర్స్ అవుతుంది, EP గ్రేటర్ దెన్ ES లేదా ES లెస్ దెన్ EP అన్నమాట. నంబర్ ఆఫ్ టర్న్స్ N సెకండరీ గ్రేటర్ దెన్ N ప్రైమరీ, వోల్టేజ్ V secondary greater than V primary, impedance Z secondary greater than Z primary, current I secondary less than I primary. Nature, primary is made of thick wire. Primary is made of thick wire. Here primary is made of thin wire. Transformer ratio R greater than 1 or less than 1. ఇక్కడ N secondary is less than N primary, V secondary less than V primary, Z secondary less than Z primary, I secondary less than I primary, I secondary less than I primary. Here I secondary greater than I primary. This is about AC, alternating current. Thank you.